Alright guys, let's go over some problems. I'm going to go over the first couple a little bit faster. We did a lot of them in class today, but I'm not going to go over the full table. Hopefully you guys can figure that one out. But number one, we'll start here. Number one, it says find the number of sides of a regular polygon if the interior angle measures 108. So we have the interior angle equaling 108. If I can find the exterior angle, then I can easily find the sides. To do that, I'm going to take 180 and subtract 108, and that's going to give me 72 degrees, and that is the exterior angle. Now, I want to find the number of sides, so I just take the 360 and I divide it by the exterior angle. So this exterior angle fits into 360 how many times? The answer is 5 sides, so we're dealing with a pentagon. Number two, it says find the number of sides of a regular polygon if each exterior angle measures 36. Okay, so well, I have my exterior angle right off the bat this time, so this one's even easier. I just take 360 degrees and divide it by 36, and that gives me 10 sides. Again, to find the side lengths, all we have to do is go ahead and divide in. Okay, number three. I know, just kind of jumping through these. Find the length of one base of a trapezoid. If the other base measures 10 centimeters, the height is 8, and the area is 100. So my area formula is equal to 1/2 height b1 plus b2. 1/2 the height is going to be 4. Base 1 is going to be 10. Base 2 I don't know, and it tells me the area is 100. Okay, I'm sorry, the height is 8. My bad. Okay, I could take half of 8, and what happens there, I get 100 equals 4 times 10 plus b2. I can divide both sides by 4, and I get 25 equals 10 plus b2. The 4's would cancel here. Subtract the 10, and b2 equals 15. Alright guys, those are the first three. Let's keep moving. Number 4, we have a hexagon. We want to try and find all of our missing little pieces here. So here's our hexagon. We got side 10. So I'm going to draw that little triangle in the middle, and the apothem comes down and breaks that into 5. So I'm going to draw that triangle out here. We have 5 down here and 10. I'm sorry, not 10. 10 does not go there. And this is a 90. Now hexagons, the central angle, to find the central angle, we do 360 divided by 6 gets us 60 degrees. So that's right here is the 60 degrees. And then divide it by 2 and we get 30 degrees. So this is 30 degrees in here, 60 degrees down here. So the apothem is actually going to be 5 rad 3, which is good because now we know the apothem is 5 rad 3. We know the perimeter is going to be 10 times 6, so the perimeter is going to be 60. So knowing that information, we can just do 1/2 the apothem, 5 rad 3, times 60, and that's going to leave us with 150 rad 3 square units is our area. Okay, number 5, we got a triangle. We're given some piece here, and 12 is here. So we'll go ahead and finish off that triangle. It's going to break this in half into 6 and 6. If you take 360 and divide it by 3 sides, you get 120, and then divide it by 2, the apothem, 60. Okay, so we get 60 degrees up here. That means 6 is in the x rad 3 position. When it's in the x rad 3 position, we go ahead and set it equal to x rad 3, which basically means the apothem here, which is right here, is going to become 3 rad 3. We divide by 3, multiply by rad 3. So there's our apothem, 3 rad 3. Our perimeter is going to be 12 times 3, which is going to be 36. So we have both of those pieces. And then we plug it into our formula. Area equals 1/2 3 rad 3 times 36. And we plug that in, leave it in radical form. And I'm sorry, not 3 rad 3, that should be 2 rad 3. 2 rad 3. 2 rad 3. My apologies. divide 6 by 3, you get 2. So 2 rad 3. Half of 2 is rad 3, and then times 36, so we just get 36 rad 3. Square units. Alright, number 6, it says find the area of a regular nonagon with a perimeter of 72. So you have the perimeter of 72, it's a nonagon, so that's 9 sides. When we divide that, we're actually going to get 8 centimeters on each side. Okay, so I'm going to just take one of those 9 triangles, and we'll have 8, which when we drop the apothem in, we're going to get 4 and 4. And to find that central angle, we're going to do 360 divided by 9. Which is 40, and then divide that by 2, which is 20. So you get 20 up here. Unfortunately, at this point, we have no special right triangle, so when we pull this triangle out, 20 degrees for 90, we have the apothem here. We're going to get tan of 20 equals opposite over adjacent, which that becomes A equals 4 over tan 20. And so that's what my A equals. Okay, my perimeter I already know is 72. And we just got to plug that into our formula. Now I'm going to use my calculator all at once. And when I do this, it actually should come up with the most precise answer, so I'm not rounding. And when I get my final answer, I get 395.6 square units. Find the area of a regular octagon whose sides are 16, round to the nearest tenth. Okay, so we have an octagon. This is not too bad there for me. 16 is the side length. So we can find the perimeter pretty easily. That's going to be 8 times 16. Okay, so when we do 8 times 16, we're going to come up with 128, I believe. So the perimeter was pretty fast, 128. Next, we want to find the apothem. Drop in that apothem, that's going to be half of that. I already did the math, but we should get 360 divided by 8, which gives me 45. Then divide that by 2, I get 22.5. So that's this angle here, 22.5. And let's switch colors up for my triangle. So 22.5, we had this is going to be 8, that's half of 16. We want to find the apothem. This is going to be the tan of 22.5 equals 8 over A, which means A is going to equal, or the apothem is 8 over tan 22.5. So those are my two pieces. Put it in my calculator all at once. Apothem times perimeter. If we get that in our calculator all at once, keep it in there, we should get approximately 1,236.1 square units. Okay, number 8. Number 8, we're using the trapezoid. It says find the area of a trapezoid, so we'll start out with area equals 1/2, height B1 plus B2. It says the perimeter is 40. So the trapezoid has a perimeter of 40, and we have 9 and 5 on the diagonals. Okay, so basically I got to take 40, subtract 9, subtract 5. That leaves me with 26 overall. So 26 is going to be broken up between the two bases. So I know base 1 plus base 2 is actually just going to become 26. The height was given to me as 5. That looks like a 6. Sorry about that. As a 5. And then we're going to take half of that. Okay, so half of 26 is 13. 13 times 5, yeah, is 65. And I believe it's in feet. Alright, last one. Last one. This is a rhombus. Remember, rhombus have all congruent sides. So here it says one angle measures 60. Diagonals bisect it, so that's going to become 30 and 30. This is a 90 degree, which means this is a 30, 60, 90. It says the short side, or short diagonal is 8. So opposite the 30 is going to be smaller than opposite the 60. So when I break 8 in half, it should go over here, opposite the 30. Well, if that's x, this is going to be x rad 3. So I should have all my diagonals. So when I set up my equation, I should get area equals 1/2 diagonal 1, which is 8, add them together. 4 rad 3 plus 4 rad 3 is going to give me 8 rad 3. And when we multiply that all together, we should end up with 32 rad 3. Okay. Alright, I believe I promised a bonus question. I think I did. Okay, so let's go ahead and get one bonus question in here. And this is a decent question. Okay, so the question here is kind of a tricky one. But my question is, here, maybe I can sketch it out a little easier.